So we have this panel session because of I think all of us knows we do what we're interested in, and one thing that's so important is conversation. And the conversation discussions, which is one thing very important thing, is should not only talk about inside one domain or inside one country. And that is actually opportunities for us from different Nordic countries that stand here. And please try to imagine Ivan is here from Sweden because he already sent me his some bullet points. So I'm going to represent him. So we have a two part. And of course, I'm going to spend a bit more time here because of Søren as a non-profit organization, which is a research institute, and which is more interested, and also which is you can share more insight. So the first part we are going to focus on research. So the second part is going to focus on education. So this four prioritized research areas, and this is also what is the 4 years this project, this EnergyInformatics.Academy project, which is we are initial identified important research areas. So later on, I'm going to explain a little bit the more here, and which is you also can see what some of our keynote speakers and touch upon it. So the first maybe questions before actually I have questions, everyone can see it. And it means I'm not going to miss any point. But the first question maybe I would like to ask Søren is, if you look at these 4 research areas, and you're talking about is you try to collect more data regarding power tracks, and that is actually we didn't put it into here, industry is because of actually it's very important industry here, and I still have been doing a lot regarding this energy industry. However, is since we have 4 countries, we decided each of country just identify one. So besides industry, which is maybe the most difficult domain which you collect data from, and for among these 4 domains, what can you just say something a little bit more about what data Central Denmark already has, and what data you are in the process to have, and what data actually don't have, and maybe think it's a good idea to have. So maybe we can start from smart buildings and grid. So in that way, is I know you have lots of data regarding buildings. And then what my question is, what type of building data you have? As maybe it's more like in details, right? So we have building data, we have building energy data. But what do we mean about that?
Yeah. So mainly what we have is the meter data. So the consumption of district heating, electricity consumption, and water consumption, and then we enrich these data with what publicly available data that we can get. So that is the BDI information on the energy label, the year it's built, how it's positioned towards the sun and so forth, square meters and so forth. And combining that with the weather data, publicly available weather data, we can see when does the building actually perform well and when does it perform poorly. So that is the data that we have in general. Then we have some of these demo site buildings where we have what you also have showcased up in your lab, that we can have some internal IoT devices for CO2 and temperature inside every room. Some sensors also can estimate how many people are in the room. We have a Danish company called Climify that have some sensors that can estimate how many people are in the room in different time periods. And that is also very interesting for see the performance of the building. But that is of course not something that is generic and something that we can get for all buildings in Denmark.
And if you look at the way I put here is a grid integration. So my next question is, do we have any data regarding distributed energy sources?
We have some projects where we have buildings with internal storage capacity, batteries, and also solar production. And here we're focusing on optimizing their economy. And so postponing and consumption, heating, and so forth, ventilation in the rooms, so that we consume when they produce their own energy. There's a not that good business case in putting the power into the grid and then afterwards buy it back. So it's a better economy in consuming internal behind the meter. So that is something that is interesting for building owners.
Next thing, of course, you can see is EV. So do you have any EV data?
We have some, but it's very difficult to actually get. We have different algorithms that we use to estimate where we can see new EVs has been connected to the grid. So you can see the dynamics of the consumption, and then we can say, okay, this is most likely an electric vehicle. So we can estimate how many are there connected to different areas of the grid.
I was thinking, if I may, is in electric driving, and we see like EV also have their own EV charging stations, and since they're partner, right, in still energy. I was wondering if they could share some of their data from their charging stations.
Yes,
because I mean basically that's anonymous, but it still gives you the behavior of a charging station.
Yes,
I mean with many EVs and patterns, maybe that could be a definitely interesting thing to get on board for that one.
And we are in dialogue with different charging station operators to how to connect to their APIs. But there's of course some GDPR that you should be aware of. But for the public charging stations, that is it's way easier.
Yeah.
Then the next question is energy communities. And when we talk about energy community, actually means is the multiple energy systems there, like electricity, district heating, and also water. As I saw you put water there. So do you really have any data for an area, which is you have energy community energy data, which means is one area you collect for one household, for example, both electricity, heating, and also water? Or at what level?
I got a bit confused about the question, because we have a lot of areas where we can combine the three different consumption for the energy sectors for one household.
Okay.
That is easy. That we have that already, but there are very little actual energy communities in Denmark, and we don't have that yet. We are building one right now in a project where it is to be tested how behavior is in an energy community, but it is very difficult, and something that we're also working with together with EnergyNet.
So that is actually mentioned in EnergyNet. Actually, it means the next one regarding electricity market facilitation and demand response. And this question actually I know through our FED and also the digital energy hub project, which is Central Denmark not only focused on data and also focus on data-driven solutions. So in that case, I would like to ask is any kind of like digital solutions or which is our tools or algorithms which can enable focus on demand response and grid integrations, and at what level have been developed or explored?
Yeah, so one approach is to use the aggregators to collect a lot of minor distributed energy resources and use them as a demand response capacity. That's one way.
So the collaborations with Central Denmark developed these digital solutions, and they are mainly SMEs, or they are mainly technology development companies or what the collaboration for what's the status?
I think we see
Sprint.
sorry.
The companies that was part of the sprints.
Yes, it's very much SMEs that have been in the ecosystem for the past 10 years. If we go 10 years back, we had a more companies working within this field, but I think we had some lack of maturity in the energy system, so it was very difficult to actually deliver and sell the services. But right now we actually see a burning platform where the utility companies need these services. And we also see more and more companies coming up with the services. But now we have maybe a handful or so of robust SME companies. And we of course have some major as well. But otherwise, it's the new companies spin out from universities where we can see that come up with the innovative solutions. So I think that is what we see in the sprint, in recent sprint.
So, do any of you have a similar question or relevant questions? Yes, please.
This might be most concerned, but what kind of data resolution are you looking for when you want to flip the demand response model in the utility?
Come again.
When you talked about flipping the demand response model in your first couple of slides, what kind of data resolution are you looking for to actually realize that goal?
It is data from the individual unit that can be flexible. And the challenge is to identify how flexible can it be. So if a cooling house is flexible in 1 hour, it can be less flexible in the next hours because then it needs to be running again, right? To keep the temperature below a certain degree. So that is something that is unique for each flexible unit connected to the grid, even if it's an electric vehicle or it's a cooling house or it's what it is. And combine that in large scale so that you actually have a capacity where you can fit into the different energy markets that is controlled by Energinet.
Yes, please.
Do you have any good way to analyze the stability of the different facilities? You say there's a wide variety for each facility, how flexible it is. Very good way to do it, like automatically in some way, or like have an index for it or something.
Once again, my hearing is not that good.
Say the flexibility varies a lot per facility. Do you have any good way to automatically assess that, like some sort of index or something? Or some good way to automate it?
Oh, that's a big topic you open up there. And in this project that has been mentioned a lot of times now, Flexible Energy Denmark, we had two paradigms that was actually battling a bit on how it could be done in the best way. So one approach is the aggregation way, where you can tip in with flexibility, and one other way is to have price signals. So where price signals is actually you can have a MPC controller or something running on a cooling house or for controlling a battery charging on electric vehicles or so forth, and see on what price signal level will an amount of flexible units actually operate or change their behavior. And then it's an algorithm controlling it. The other way is having a market for flexibility that is not there today, where you can tip in with flexibility to, for instance, an aggregator that can then tip into the energy markets. So, but it is different from unit to unit.
I think just comment on the two solutions that Søren is mentioning for the flex. That's a flex offer, where you can bid into a flexibility market. That also have become a company as part of the sprints, and the other one is a flexibility indicator. That is a mathematical function for estimating what can be the flexibility of a load. That was developed as part of Annex 81 that actually do the flexibility indicator on buildings, but it's also applicable to other loads. Yeah, where you can search them and then they will pop up. If you go on Google.
Good. So for the rest of 6 minutes, I'm going to ask some questions regarding education. Okay, the education actually, you can see, what we know, the education program usually have a bachelor, master, and a PhD. And then my first question I would like to ask, of course, to Søren, and for your company, what currently what type of the employees and backgrounds they've come from, and what levels of education, or maybe it doesn't need to be only the three of them, maybe something else. So can you give us elaborate what you would like to have people on board in your company?
In my company,
If
Yes.
you could go on, just choose and pick them, they're available.
Yes.
The educational level is not that important, actually. You need the right competences, and you need the right personal behavior and approach to innovate and understand new technology. You need the cognitive bandwidth to cope with a very complex world with new energy technologies, big data, AI, and so forth, and put that into an understanding and discussing it in meetings. So I think it's very much more a matter of personal competences and personal behavior than its educational level. Sorry, but that's how I see it.
But I don't know if I may supplement, because you actually said it in your presentation, I think. Because you said, this basically we're referring to the educational silos, right? I mean, typically you have people who have maybe a background that is purely energy related, like electrical,
Yes.
kind of mechanical control engineering, or you have something that are purely like in computer science or software engineering or some other of the many educations that touch on digitalization. And basically these two, it's separate people. Very often not inside the same body. It's not inside people that these things are combined.
Yeah.
So, and how I heard what you were saying, you were basically looking for the people who know both things.
Yes.
Right. That's why we do EnergyInformatics.
Yeah, and it's absolutely good. It's spot on.
I was waiting to sneak it in.
Sorry, I didn't say it myself, but you are spot on here in what we need.
Yeah.
And I think then it's the curiosity of understanding new technologies. This tendencies is accelerating. So you cannot, after finalizing a master or PhD, just say now you know everything. In a year or two, it's very much difficult. But many of our colleagues are PhDs and masters of different sorts. Software developers, data engineers, and data scientists, and energy specialists. Yeah.
Then maybe my last question I would like to ask is based on your interactions with different type of energy related companies, like I cannot say state owned, but like Energinet, like utility companies, and like this technology solution providers, or maybe also consulting companies, and what their background they have, and what you think is missing in order to reach the future trend, because of of course people already have their education what they have, but in order to equip our students, which is can fulfill the future market, or after graduate is not out of date at least, right? So what's the competence and what's the skills and they should have?
Yeah, I think I can only say that dig into all the technologies that you can get in touch with. Be curious on knowledge and continue to do so. And for the utility companies, I think it's not only a matter of having one department with the competences for digitalization and energy, because digital solutions tend to go across organizational barriers. So we need to raise the maturity, digital maturity level in the entire organization, as I see it, for utility companies.
I think we can open up for one questions, if any of you, yes.
So Søren, you said that there are some spin-outs from universities that provides value based on your data. So how do you target the universities? How do you make them aware of your existence and your data? Do you make some, or have thought about make some small sprints or projects in collaboration with students?
Actually, I don't think we are doing well enough on that field. We should do even more. So thank you for the question. The way we do it today is through the relationships that we have with UBO and other professors on the universities, where we have a collaboration, and then they involve their students. But we could and should be more proactive. Yeah. Thank you.
Yes, and allow me to have one more question. Yes.
I'm an engineering student, so I can actually say something about this. In terms of, I guess, fostering a more innovative mindset for the future, because I'm pretty sure we need that. We have a course, I'm not sure which semesters it is for the other degrees. It's called Experts in Team Innovation. And my experience is that, I don't know how to put it nicely, not a lot of people enjoy that course because one, I think it's very inherently difficult to explain the value of why people should work together to a lot of students. I guess. And it's also just sort of hard to, build an environment where you tell people it's good to work together, it's good to do good, it's good to take care of, the environment and design for longevity. And it seems like it, or at least in my view, it has been like that for a while from the university side. Could we maybe change something about that? Maybe the wrong people to ask. That's
It's I think
comment to this because in my earlier company we were very much engaged with now and just say this example with GTU. They have a program which is called the Innovation Pilot, and for some of the students it's mandatory to take it. And then you are invited as a company. You can give a pitch with a concrete problem you have in your everyday working that you do not have the time and resources for. And then a group of students, minimum 6 students from minimum 3 different directions and fields, have 3 or 6 months part-time to work on the program, and then they pitch back to you to convince you something. And I must say that every time it was a different problem, but also different fields of students, and we were always very positively surprised what we got out, that an electrical engineer together with an economist and a marketing student just needed to work together and try to convince us. And that was actually, I have always had the feeling that both students and the companies were positively surprised by the results. And I have actually, in the 3 years I was participating, also seen patents came out of this, funding came out of this, student scholarships came out of this, so it was actually very successful.
Well, I think this is what our SDU definitely have to work on it. And I think with great collaborations with Central Denmark, and we can provide something similar, we make even better than it. Sorry to have taken myself. Yes, now we have a goal here to improve it. Yes, I think it's time's up, and we have lots of questions we'd like to ask you, but we hope have next time.
Yes, thank you.
Thank you very much, and have a nice trip. Great feedback.
Thank you, guys.
Yes. Yes, so the panel discussion still continues, and since we already go to the.
That's all of the questions. Yeah.
Yes, very nice. And now I just like, you can just walk around, you like see it's fine, and it don't need to be, this is the final part of the day, right? So again, as that, if you look at it, actually, when I check about what MSc is, it's not a master in engineering, actually, is a master of science. And here I changed it actually basically because of majority of us, at least physically, as I can see, is from engineering background. And this is actually, if you look at it from engineering track, bachelor, master, and PhD. And of course, majority of, for example, in Denmark, we usually go from bachelor to master. So when you graduate, actually have a master degree. Bachelor is more like just in the process. But however, it's the international way is we have this 3 level of education program. I think it's in your 2 countries, it's relatively similar. And actually, we have some questions we would like to ask. Things is this education, and we know, Søren mentioned about is he wants to this bridge out, see some gap between the people who have education from have energy background. Actually, they are lack of this digitalization of informatics perspective, and then people who's from this data science, computer science, and software engineering actually lack of this energy knowledge. So this is actually I would like to ask about in your 3 countries. I know in Norway you mentioned something regarding this educational program, which is in EV related. So then actually basically I would like to ask you, 3 of you, is what's the current this educational program, including these 3 programs, which is relevant to energy informatics. And I would like to start from lady first, and then of course our international guest.
Okay, so I can speak from the UIT side, because this is where I know most what is happening. So I know that at the physics department, they have this study program that is called Energy, Climate, and Environment. And they also have this renewable energy study program. And in this study program, they are, of course, having a great focus on energy technologies, and they have courses on power systems, and they also have some courses, foundations of computer science and informatics. So I think it's a pretty interdisciplinary study program that is quite promising, but it's not, I don't think it's fully what an energy informatics study program should be. And then what we are doing at our department, because our is a department of computer science, in the last few years, we started developing different self-contained courses, which try to address some specific subjects that fall under the umbrella of energy informatics. So, for instance, we have a course on smart energy and power systems modeling, and this is, mathematical optimization, but very much focused on energy and power systems applications. There is a course also on green computing, because green computing anyway is also part of energy informatics. And then we have quite a strong cybersecurity group in our department, and we are discussing the possibility to develop some optional courses on cybersecurity and the smart grids. So we don't have yet a plan for a full study program, but what we are trying to do, at least, for us interested in the energy informatics domain, we're trying to develop different optional courses that fall under the umbrella of energy informatics, so that we can also see the reaction of the students and what kind of interest is out there. And then we take it from there for a development of a study program eventually.
Thank you. How about in Iceland?
Well, if I start with the PhD program, there is no structured PhD program, there is the content. So if you have a PhD student, it's because a researcher has a grant on specific topic. So it's not the department or the faculties having a master plan. So that's, you could basically say it's random. Basically, it depends on the researchers themselves and their interest. If I go down then to bachelor master, which is our, then we have a master plan, we have a program. Civil engineering, very standard, it's hydrodynamics. It's not energy informatics, it's more like about the classic civil engineering, making dams and so on. Electrical engineering, unfortunately, is not focused on electricity. They're more on signal processing and then in image processing. That's actually the Faculty of Electrical Engineering is top number 4 in the world in remote sensing. So they want to keep that, so they focus on that. My faculty, we have a mechanical engineering. So mechanical engineering, we have a specialty there. It's energy, renewable energy. The focus there is more on classical mechanical engineering. So it's corrosion and erosion and geothermal mostly. We have computer science. They work with any data, which is AI and they love data and HPC, high performance computing. So they're working a lot with Germany. Funny enough, so I belong now to a department called Industrial Engineering. We just recently changed our program, and I would say that's probably the closest thing to energy informatics. But we talk about data informatics and data this and data processing and so like we're not putting energy, but it's probably the closest thing that we have on informatics and so on. So, but it's not under the umbrella of energy.
This is something which is, I think, both can follow up with what happens in Denmark.
Yeah, I mean, well, everything what you say, like PhD programs is the same, because we just have a PhD in engineering.
Yeah.
No matter what engineering you are, it's just a PhD in engineering. And then you have to try to delete it out of the title that was on the PhD thesis, where you think that student belongs.
Yeah, exactly.
So we don't have that. When we go to master and bachelor, of course, we don't have a dedicated program in energy informatics. We have like our energy systems, and if you go across Denmark, there's also no programs in energy informatics. We are working on having one program, but again, I mean, the time it takes before you go through the approval process and before the first candidate would be out there. I mean, if you look into if it should be a full program with bachelor and master, and then you are looking into 7 years from today. And we should have applied before summer vacation. Maybe more 8 years before the first candidate would actually, reach the ground running. And if you just look at making a master, then it's 5 years from now, just because of the whole approval process and all these things. So I think my comment is that our ministerial system is totally outdated to follow up with reality. I mean, if we want to say that the education should have a label, should have a name in order to reflect what they are, because I mean, that's just too slow. So of course, the way, we can then try mathematically to bridge the gap is, of course, you make different courses and try to do it within the approved programs of our educations. But that's never an ideal way of making anything. So it's
So before I ask the follow-up question, any of you have any questions or any comments on the current education, please?
Yeah, I can see the word evolving actually in your slide. So that shows, and I agree with that actually. Energy informatics is evolving, and the speed is quite high. So I think this is the comment. So if we have the program should be a bit flexible, meaning that if we can have 1 or 2 courses, like, titled like a special topic in energy informatics, something like this, that you can actually train a student to reach certain level, of the skills to do collaboration with company or do some specific task for a company. That would be, I think, very good.
So for,
I mean, this flexibility is nice. I would say, now I've made many education through my lifetime, 5 or 6 now, and we have been on a journey. I mean, many years ago, when I was a student, we had more like a more traditional systems. You got a major and minor, at least if it was natural science and engineering. Okay, that was very sectorial. And I was in education that back then was called data technology, that later became robotics. That was a little bit more, interdisciplinary, cross-engineering faculty. But there was certain flexibility, and it's still due to these blocks. Then we had governments, they come and go, and all of them have an idea of what education should look like. And sometimes we have some minister who's more strong. And then at some point they wanted the young people or the students, they should be able to see from the title and the full education description exactly what that job was going to be. So there was a lot, restrictions on actually how you could make your educational programs and construct them. And then basically a lot of this flexibility totally disappears. Now I think there's a small trend towards we can try to make things a little bit more flexible again. But again, the whole process of having anything changed, I mean, change the name of an education or change a little bit that relates to actually what is the competence profile, then you almost have to have a whole new education approved. And when you look into at least 2 years. So the flexibility is quite difficult.
Yes, thanks very much. And basically my follow-up question is, since the current education program seems like not covered both the digital informatics or energy, which is the topic, the scope here today. Then my question is how we can ensure we can incubate. I don't want to say education because of the university should be a place really equipped the graduates. If we don't have this kind of education program, how we can ensure we can incubate the competence people, basically graduates what the industry, the job market need. So this actually means if you look at, then maybe easier to answer the question step by step. I would like to ask you what's the skills and competence for the future professionals?
I think the skills and the competences we already talked about, in order to be able to know both domains, be able to bridge them.
Mm-hmm.
But I think we do have some tools we can use.
Mm-hmm.
I mean, we also have the bachelor project where there's a kind of a flexibility. We have the master projects also where there are flexibility. We just got a new 1-year master approved. I mean, master project that we can do for our energy students, where I actually can have much more energy informatics in the master thesis. That gives them more time. We have the elective courses that also give certain kind of flexibility in what we choose. So I think there are mechanisms to work with, but people will not get the stamp when they leave that you've got a master in or bachelor in for instance, in informatics. But I think they can create that profile and get the competencies like Søren was talking about, both energy and AI and geoscience supplements.
So you mean your student graduate from your education, you can say they are good enough to fulfill this profile of energy informatics?
Søren talks all the time.
Okay.
But I mean, it depends on actually what you do in your bachelor and what you do in your master, because that's where you get the elements of specialization together with the elective courses you can take. Then you can make sure you can bridge the fields.
I think everyone proud of their own education program. So I would like to ask yours experience.
Can I start? Well, we've often said our graduate students are overqualified for the Icelandic market.
Yes.
The Icelandic industry is very primitive. So you learn all these nice tools at the university, and then you start working, you only use Excel. But we've seen mechanical engineers, PhDs in mechanical engineering, they start to work at banks, financial markets. We didn't teach them that. Somehow they just find a way and they do quite well. So I'm not worried. Actually, if you have good students graduate, they will have the skills. But I think, and this is what we did for industrial engineering, we see that programming skills with statistics, because you can model up to a certain thing, but if you have too many variables, you just have to take statistics and distributions. And so we do a lot of modeling using that. Then you can apply it to this and something else.
Yeah, I can see is that our young people don't need to care, don't need to concern about the future. They are going to have a bright future, 100% sure. Great. So how about in Norway?
I think that in general, I mean, not only Norway, I think, you know, to educate these energy informatics specialists of the future, I think we should provide more highly interdisciplinary courses where the students have to put together different subjects. Because, for instance, now, if we think about how education is organized, mostly, I mean, you will have, for instance, a course on optimization, and then it's just the methodology, a course on machine learning, course on AI, but in none of these courses, actually, since they are focusing on the methodology, they are not explaining the application energy power systems. So we should rather have optional courses or some offering where, for instance, we teach like optimization for energy and power systems, so energy systems modeling, or for instance, we teach big data analytics for energy networks. And this way, the students have a course where they can see both sides of the subjects at the same time, and it's easier to attract students from different departments. And this would create also cross-departmental collaborations, because then the students might come for a master thesis, and then you could co-supervise with other departments. So I think that the content of some courses should be more blended somehow.
Yes, I think it's all this.
We agree on this. We often talk about tools, so a lot of courses are just tools, but you need to teach them problem solving. So here's a problem. How do you deal with the problem? How do you formulate the problem and all that? That's actually a skill that engineers need to have.
And the problem formulation anyway should be specific, because, you know, the energy field has some, you know, need some specific knowledge, which is different from like health people like applying data analytics or health related issues. So each field has some peculiarities, and this should be part of the course.
Yeah, I do wish we have some education to the high school students. From the educational title, they can choose the education program, which is you described, give them a bright future. Is any questions? Otherwise, I'm going to ask, yes, please.
I have a comment. So I think we could also maybe state the achievements, because we are already gone quite far, I would say, in the last year. So my education is started more than 20 years ago, and I have still more than 20 years on in working. And I must say, my education was very much focused on knowledge. So people thought you are 4 years, you get knowledge, and then you can go out, and with this fixed knowledge you can serve 40 years working. But today, it really is actually, since everything is going much further, knowledge development, change in businesses, you need skills and competences to educate yourself in new stuff, new technologies and things like this. And this was also what Søren mentioned, this curiosity and eagerness and openness. But we have gone quite far there. The young students today are, I would say, much better when they finish in being mission-driven or problem-oriented than I was when I finished the university. So we've achieved quite something, I would say, also.
Good. So my last question is actually to go back to, is any kinds of like, for the students, they have the opportunity doing this kind of semester exchange or anything kind of like go to visit your country to study for a while? I mean, any opportunities you have international program for international students?
Yeah, I mean, we teach in masters, we teach in English, so we have a lot of foreign students in the master's program, but in the bachelor, we will try to teach in Icelandic. It's not always happening, but it's, I think my problem mostly with collaborating with universities, let's say in Europe, is the semester system, because sometimes they have the semesters going over, let's say, the new year. But we start in August, we end in December, we start in January, we end in May. So it's very clean, and then we have summertime. So sometimes that does not fit the other schools, so the universities. So that's the main problem.
Yeah, we start in September, ends in January, and starts in February, and ends in June.
Yeah, so February, June.
We already, yeah, we already out of sync. Yeah.
So how about Norway?
Yeah, Norway is actually similar to what he was mentioning. So we have masters, we teach all the masters is in English, and the semester is organized exactly as he said. And we have some, students coming like on Erasmus or exchange. And I know that the Norwegian students, master students, I think they can apply to his Lånekassen or to get some funds for a period abroad also during the master studies.
Good. So I think for both physically and also our head of education is over here, and also online participants, and there's opportunities to visit this actually 4 countries. I think for Sweden is also relatively similar. So the times go fast, and if any questions regarding education, okay, perfect. Happy to hear. Other Chinese originate, I really sometimes do like people respect, no question is good. Yes. Okay. So let's go back to this research. I think it's majority of us come here is because of the research part. And if we look at it, there's 4 areas we identified. As I said, industry is very important, and we have done quite a lot. But today I just try to focus on the 3. So I heard all of yours this keynote speeches, and you talk a lot regarding these challenges. And I would like to you just maybe just very fast think about, okay, if there's any challenges you get mentioned. I was thinking is maybe it's challenges from your experience. I mean, in your country, how about the challenges you think or you experience for this kind of like Nordic context, which is you would like to mention?
Well, challenge in Iceland, most meters are analog or mechanical. So for example, hot water is just mechanical, and you have to do the reading once a year. So it's just aggregated for 1 year. They're trying to have not digital sensors, but we have to wait for them. Smart meters for electricity, they are introducing it. But the utility companies, some of them just read it once a day, others read it once an hour. But you still have majority is just analog, and you have to go physically and read them. So it's the quality of data. It's basically data. We need data. But also the electric, the charging stations, they have nice data. They actually showed me, you can see the charging curves of each car. You can identify, this is Audi, this is Tesla, this is Audi, because they have so different charging curves. That's interesting data, but we don't have access to this.
You don't share. So how about in Norway?
Well, I think so, and we saw in the presentation, Norway is doing pretty well with this electric vehicles adoption. So I can think about challenges in terms of research. I see the challenge of computational complexity. So for the development like of these models, these multi-horizon models, longer term and shorter term uncertainty, then you need powerful computational resources for them. And then I would say another challenge can be in the like data for drivers' behavior. For instance, when I was talking about this project on that was integrating the concept of elasticity, I mean, still this type of data in terms of the driver's sensitivity to prices, there was still quite a lot of work to do.
Yes, data access, data sharing, and anything in Denmark, we have different challenges.
I think basically, provocatively, I would say there's nothing left to be done. All engineering problems have been solved. We already have all the solutions for the next coming time horizon. I said provocatively because smart meters, everything is out there. I mean, you can buy everything, but there's no incentives for doing it, or there might not be regulatory rules that enforce you to do so, but there's no business model that helps you to do it, or there's GDPR that prevents you from actually having access to data, or you might even have a court system that tells you to roll back the rollout of smart meters like they had in Germany. So I think in the short time horizon, all the problems are not really technical. It's a question about creating business models and incentives and get things done. Then, of course, in the longer horizon, there are things to be done when we learn from rolling out all the technologies we already have. And there I think the challenge is a little bit what you asked Klaus about this morning, about the mismatch in funding schemes with respect to collaboration across borders. Because as we know from all these different funding schemes where, yes, it might be kind of a common project across European borders or Nordic borders, but the thing is you need them to go to your national funding agencies, and all of them have special rules. So there I think that's a barrier for accelerating, research and development across borders, and also in order to include companies within the different countries.
So any questions you would like to ask specific? Okay, then actually I would like you to become a little bit more human intelligent. When we talk about...
I'm an engineer, so...
Yes, so actually when we talk about AI, artificial intelligence, we always try to develop these AI models for prediction, right? And this is what we're so fond of. Now I would like to ask three experts, and since you not only have intelligence because you get a PhD degree, right? And also because of you have lots of training data, you have past experience. Now I would like to ask you is, what do you think the research trend and future focuses in the Nordic context or in your own country is going to be like short term, let's say 2030 is short term, and long term is 2050. What do we expect going to see? Or to consider, now we need to prepare because it's going to come. So maybe it's, I know both have done quite a lot of AI. And so that is, I would like you to start to answer this difficult question.
Well, I mean, there's a lot of work being done on all kinds of forecasting of consumption and production, and how we can try to use that to balance the grid. If we have access to data, it's really not so difficult. But in order to really use it, then we are back at what I said previously. I mean, because if we really want to bring this into use, we all the time run into some barrier of how we have organized those electricity markets and that are built on. That was why I showed the tree this morning. After we have all these past decisions that determines our future, and we need to develop these solution into that future scenario. The solution to this future scenario. So there's a lot of work being done, but it's not really so applicable. So I think that's the trend should be maybe that we should be very much aware when we as researchers we try to positioning our research. We should remember to also write in our paper what is our assumptions and what is the context in which we believe this research applies, in order maybe to make the impact bigger.
Now maybe let me reform questions a little bit. Another way. When we're talking about informatics, big data, IT, ICTs, and AIs, as you know, is nowadays the world is so busy in large language models, and what is also other AI development, but it's not happening in Europe. It either happens in US or happens in China. And then the question is, what Europe, especially Nordic, we should consider is our future trend is we can be the pioneer. One of the reasons why we have this summit, we think it's important for us to stand here together to look forward, say how we can make Nordic. I'm not saying it's a great again, sorry to say, but how can make Nordic is recognized, in the energy informatics field. It's not always heard from US and China or even Germany. So this is I would like to ask you the research trends, future focuses, which allowed us to make us have identified as the pioneer. Or maybe you can answer me whether it's possible.
It's really big question. It really depends. I mean, tomorrow we might have a great idea, but currently we're just addressing current problems because we need to solve them. And for example, in Iceland, if I finish, in Iceland, I see problems that I've seen problems in other countries. So I visited South Africa last year, and they have this power shedding. So you drive through the country and suddenly there's no power where you're driving. The traffic lights go out. You were at the gas station, power goes out. You have to wait 1 minute, you hear a diesel generator come on, and they're just rationing the energy. But this is because they say because of corruption, so they're not maintaining the power plants. I see this is they're slowly starting to warn us in Iceland that maybe they need to ration, because we're not making new dams, we're not making new power plants. So the CEO of the biggest power company is starting to warn us. And so if it's difficult, right? I would like to quote Niels Bohr, it's difficult to predict, especially in the future. I see this coming somehow that I would, and I like to have batteries in the house. I'd like to survive at least 1 or 2 days easily if the power goes out. But if we're able to predict this, reading the energy data, and when we can see this happening, then of course, prediction is always good if we can use the data to help us.
I think Gunnar will.
I would say, one thing where, since you mentioned AI, where we've been quite good, I think when you see Norway, Sweden, Denmark, and Germany together have been very good in the last years in using AI to actually develop computer-based new material combinations and initially test them for using in renewable energy, both PV, battery, final constructions for windmills or something else. And there we have actually seen that, I think there was a paper in Nature, the last 18 months, we initially tested more combinations for batteries, secondary batteries, that we have experimentally investigated 40 years before. So this initial step, just to find out which works and which is worth to be synthesized in laboratory to go further, this has accelerated very much. And even if battery production today is somewhere else on industrial scale, I would say that Europe is leading in some of the computer-based early research and development tasks there, and also this energy intelligence that you have this knowledge about wind power and solar and the batteries in operation, how they aggregate this with this swarm intelligence and hybrid use cases and things like this. There you can also see that American and Asian companies are actually buying this knowledge in Europe. Because I would say that there are some fields where European companies and researchers are quite good using these technologies.
I think this is a very strong point. If you listen to the users, you will get the ideas. Companies that isolate themselves and just invent, they may not be addressing the needs. So it's actually a very good way for innovation is to listen to people who are installing, who are using this, to get ideas for new products.
I think what I've heard from you basically is GDPR actually is not a prevention, actually is some motivations, motivate us to develop some technology solutions which can protect users and make user friendly. And it's actually a very good point because Europe we spend so much effort on this have this protected environment, which is care more about the citizens and the.
But GDPR, I think it's a terrible thing. So I can tell you, as a head of faculty, I cannot look up students that are in my faculty. I have to contact the office, even though this is just recently recruited one person. This is the first day. That person can address everything. I cannot.
But I mean, the problem is we cannot have any data-driven innovation with GDPR. I mean, it cannot happen because the issue is that, and that's, you know, even though when we created the FAD project and wanted to create some in Denmark, is that it should give the opportunity to make data, raw data available. But the thing is that the only people who might have access to raw data is researchers, if you fill out a lot of paperwork, because there's a special law in Denmark that gives you that right to access it. But it takes a long time now to do all the paperwork. But it's important to notice here, researchers. Researchers are people who are employed. It means that no master student, bachelor student, or any student can access the data because they're not employed, they're not researchers. So they need to have anonymized data, which is often aggregated data that's useless. And of course, we might be able to use synthetic data, but it also means we need to learn ways of making synthetic data that truly represent the, properties of the real data. That, of course, that can be our benefits as researchers because we do have access to the raw material, but then it's also maybe our responsibility to create the synthetic data.
It makes everything very different.
Yes.
Do any of you have any last questions? But Otherwise, I have left quite a lot of questions here, but actually during the whole day, I hope you already find out some answers. But if not, please welcome to contact them, other questions. Of course, they're also welcome to ask me. So let's thanks the keynote speakers and gave a very good discussions regarding these two things. Thank you very much.
Thank you.